and welcome to Graphic Card Repairs. My name is Fraser, and today we have a Gigabyte RTX 2080 Ti. So I got this card, and this is the way I received it. It did not have a cooler attached. The cooler is here, and when I received it, this is how I received it without the cooler attached. And we have a dent. Okay, this thing is bent. I don't know how exactly it's bent. And the user says that this card is not getting detected. I don't know if it's bent after it was dropped or something, but it looks like it was dropped because of this bend. We'll straighten this out later. I just started off the video. And apart from that, there's a capacitor. Let me show you. This is the capacitor. And it has broken off from here. Okay, so just like these, the other capacitors, these are all capacitors. And there's a capacitor broken off from here. We may have to fix that. But apart from that, let's take a look at what else we can find. But to start off, we'll take some measurements, the main voltage rails, and see if everything is working or if we have any short. Okay, so let's check it. So we'll start off with the 12 volt PCIe. And it's in kilo ohms and rising, and we don't have a short. Let's take a look at the 3.3 volts. Okay, that's also in kilo ohms and rising. Let's take a look at the 12 volts, 8 pin. Okay, so we have about 342 ohms. I'm measuring on the shunt resistor. Let's measure it over here. And it's the same. We get about 342 ohms, which is very less, way too less. And let's check over here on the second pin. And the second pin is fine, which is rising at about, it's in the kilo ohm range. So we have a short on this 8 pin, but it's not a direct short. Okay, it's something to do with low resistance, which is 342 ohms. So we will find out, or we will try and trace what that resistance, or where's that resistance coming from. Okay, before we do that, we'll also see and measure and check if there's anything else that we can find. So I don't have the diagram of this right now handy with me, but let's measure the rest of the inductors. And whatever this one is, it could be a 5 volt or it could be the 12 volts. And we have about a kilo ohm and rising. So I suppose this inductor is for this connector here, because the reading I'm getting is same or very similar to this one. So it might be 12 volts. This might be the second 12 volts. And yes, it is. This is the inductor for that, and we get the same reading here, which is 344 ohms. Okay. Now, if this might be the 5 volts, and we don't have a short there, let's take a look here. And this is in mega ohms. I'm not too sure what this one is. I will have to check, but we don't have a short here. This is another 5 volts. And we have about, almost a kilo ohm. Let's take a look at this. And we have in the mega ohm, so there is no short. Let's take a look at this inductor. we don't have a short here either. Okay, so we don't have a short on most of them. Let's take a look at over here. I suppose this could be the PEX. Yes, it is PEX, and it's about 4.4. It's a little bit low, but low to my liking. It should have been around 9 ohms or so, but it's around 4, which is a little bit. What should I say? Maybe something indicates that something might be wrong with the core, but we'll come back to that. This might be 1.8. And we don't have a short there. Okay, let's take a look at memory. And memory, we have about 35 ohms, and this is micron. And it might be the 2018 one. Okay. So the customer did not complain of anything about memory. He said that when he was using it was fine. This was used with a water block. And during shipping, he said that there was some kind of a leak probably, and that may have caused a short circuit. Okay. There's a fuse here. We'll take a look on both the sides of the fuse, and we don't have a short, so the fuse is okay. Most of the readings are fine except for this particular 8-pin, which has a low reading. This having a low reading, we might have to trace and see where or what exactly is wrong. Okay. Now what we are going to do is we will also check voltage, but before we do that, we will just take a look under the microscope and see if we can find anything there. Let me just take this multimeter out of the way. Okay, let me switch over to the microscope. There you go. Okay, so let's take a close look under the microscope and see if we can find anything, something that might be concerning or might cause problem. So the user said that he had given this card to another repair center. It was there for quite some time, but they couldn't find any fault. So he got it to me. I agreed to accept it. And let's take a look. Okay, it looks like some kind of could be flux, but it doesn't look like some kind of a liquid. Which was around here. So I'll just make a note and check where this circuit connects. I don't know what that is. and that liquid was around here. Okay, so most of it there looks fine. Let's take a look at the back. Okay, so I also see some kind of a damage. Let me mark this point here. And a capacitor here is missing. Two capacitor here are missing. I suppose a capacitor here is also missing. And I think this circuit is also missing here. The capacitor, the resistor, two resistors here, a resistor and a resistor here. Okay. Okay. Looks there's some more damage here. Looks like a leg is missing here. So I really wonder what happened, because for a leg to go missing something like this, it must have suffered a really hard drop. So this chip is very similar to this one. Okay, so there should be, this is a 5-legged chip, and one leg is missing here. Okay, let's continue. Okay, a capacitor is knocked off here. Looks like someone tried to solder this capacitor, so because this doesn't look like factory. Probably someone was trying to look something in this particular area. There's flux as well. And a leg of this chip is also missing. Okay, so quite a bit of parts that are missing, which I may have to borrow from another card. Looks like this capacitor is also knocked off. So I think for me, if someone has tried to use this as a scrap board, I don't know, or maybe the user may have given it to someone who tried to use it as a scrap board. Okay. So there are a few things that I have to look at. The main area is here, this area here, this area here, a capacitor here, a capacitor here, a broken leg here, a broken chip here. Okay, and I think we may have to keep looking, till we solve the problem. So what we'll do is we'll start off from the first problem that we found. Plus, there was some liquid at the front. We'll come back to that later. So I think we'll start from here because there's more work here. I don't know what was really done with this particular board. So before I do anything, let me start off by taking this the front plate off, or the IO plate off, and we'll take a look at that later. So I'll quickly pause the video, get this plate off this this board, and we'll start off from there. Okay, so what I've done, I'll just show you what I've done. I've just put this card on these standoffs so that I can get a level ground while I'm doing the work. So, because otherwise this has these connectors here, and they will lift off the the card on one side and it'll be down on the other. So it's going to be really uneven. So to get rid of that, I have attached some standoffs so I can get a level ground. So to start off, what I'll do is I'll start working on this area here and start putting the resistors and capacitors that are missing. As we go, I'll replace all the parts. I know I should have checked if there is some kind of a thing, but I assure you that nothing is going to start without these parts. So it's only after I go ahead and make those changes, is what I'm going to get, the rest of the card to turn on. Okay, so let me quickly change over. Okay, so I have a donor board. I'll show you the donor board that I have. This is another 2080 Ti. Let me show you. This is another 2080 Ti, and I'm going to take some parts from here. I've already used a lot of parts from here. As you can see, there's a lot of flux that you can see around. Okay, so I will use some of the parts from here and then move them on to that particular card. So I'll just pause the video while I get this card ready to take the parts off. Okay, so the capacitance there is 1 nanofarad, and the donor board that I have is not exactly the same. So I'm going to pick one from here. So this is a 1 nanofarad capacitor. Okay, let's check the reset and a reference clock plus and reference clock minus. They're both the same, so which is good. Okay, we have replaced the missing parts, and so that was quite a long repair where we had to go ahead and replace those. Let me just switch over so I can show you what all is been replaced. So all these parts here, 1, 2, 3, 4, 5 resistors here, one capacitor. There's one capacitor here and one capacitor here. It's been replaced. This, I think I just retouched it. And there, I think there's one capacitor here that was replaced. So I think there were total. Apart from that, we have this chip here, which was replaced from a donor board. And this chip also connects to this on that donor board. So I haven't checked this. This one here has also been replaced. And I think the rest of the circuit is fine. There is one filter cap which is missing here for the memory, but we will come back to that if it causes a problem. And if we have a no detection issue, even though if we have all the voltages, then we will go ahead and replace this capacitor as well. So just to tell you what are the values that I've replaced, all the resistors here are all 0 ohm resistors. So all the ones here are 0 ohm. This particular capacitor is 103, so that's about 0.01 microfarad. Micro, or I think it was. Yeah, it's 0.01 microfarad, and that is this capacitor which is replaced. These ones, the ones on the top, I think these ones are 1 microfarad. Those are these ones that I've replaced, 1 microfarad, and there's another one that I've replaced. Oh, sorry, these ones are these ones are 1 microfarad, sorry, and these ones that I replaced are 1 nanofarad. Apart from that, that's about it. So now we will go ahead and check if we get any any voltage or any voltages that are missing. There was something that we discovered in the front that was about here. We saw there was some kind of a liquid or something that was around here in this area here. We don't know. It was dry. It looked like some kind of dried soda or something. We don't know for sure. Okay, so I will go ahead and connect my power supply and see if I get all the voltages that are required. So I'll just pause the video here, and I'll continue once I have my power supply connected. Okay, so before I go ahead and connect any power supply, I just want to check the resistance on the 8-pin. On the 8-pin 12 volts, and I still have the 3.40, which is absolutely low. I will have to go ahead and check what's causing this. Even if I inject some voltage, it will not show me which one is faulty. But let's check where I get the, let's try and trace that resistance and check where this 8-pin connects. So I'll just refer to the schematics. I have opened schematics on, I don't have, it's on a different PC completely. It's not connected, so I won't be able to show it to you right now. But I will go ahead and check the schematics and I'll come back. I'll just pause the video. From the 8-pin, that's from here, this 12 volts, it goes on to this shunt resistor. And from this resistor, it goes on to this inductor. Okay, now from this inductor, from this side, it connects to two chips. One is this one, and one is this one. This one, there's no number around here, but this one is, the number is 813, and this one is U14. So it connects to both. Now this chip controller also connects to the other 8-pin. That's why I don't suspect anything wrong with this particular controller. There might be an issue with this one, because this is connected only to that connector, or the 8-pin, which connects to 12 volts. So this might have a problem. And it also connects to two of these, MOSFETs. And it also connects to 4 at the bottom here. That is these 4. That's 1, 2, 3, and 4. Okay. My first suspicion is this chip here, which is this one, which I will try and lift first and see if my short goes away. If it goes away, then I'll just replace this chip. If the short doesn't go away, then I'll trace back again. Now you might be wondering, why am I not injecting voltage? Now the resistance is not 0, but it's absolutely about 344 ohms, so which is high enough. Even with injecting voltage, it's not going to do any or show anything different. It even on a thermal camera. So so we have to do it the hard way. I will try and lift this one. Now that 12 volts comes on to pin number 2 here from the from this side to the second pin. The 12 volts comes in here. I will lift this one first and see if that solves my problem. If not, I will go ahead and trace further. Okay, so let's start. Let's take a look at the resistance, if the resistance has changed. And you can see, okay, let me check this. And you can see the resistance increasing above 0.5 K. It might increase because the preheater is still on. So I'll just wait for the board to cool down and see if it makes any difference there. Okay, so I'll just pause the video, wait for the board to cool down. Okay, it's slightly cooler. The board is not cold, but it is slightly cooler than when I first preheated it. Now, if I measure the resistance there, it's not exactly, remove this. It's not exactly what I expected it to be. It's around 400 ohms, and it's going lower. So that indicates that this particular chip is not our culprit. It's something else. So we might have to go ahead and trace it. We are still, and as the board is cooling down, the resistance is also dropping. So our culprit is something else, and it's not not this particular chip. So I'll go ahead and install this chip back, and then I'll go ahead and check what exactly, or which other chip is causing the problem. I'll trace it further. I'll just pause the video here. Okay, let's prepare to install it back again. Okay, so what I will do right now is I will inject 12 volts from my custom power supply, and not from the main power supply which connects the PC, just to ensure that I can control the voltage. It won't take in more than I have a fuse, and let's see how it goes. Okay, I'll just pause the video, connect the power supply, and get back. Okay, so I have gone ahead and connected a wire. I've connected my power supply here. It's connected directly to the shunt resistor, and I am initially going to start with low resistance. I've also got my thermal camera ready here. Sorry, no, not low voltage, I mean. And I will connect one of the side to there, and I will first try and check if I'm getting that voltage down on this side. So just to make sure that I'm not getting shorted, so I'm going to turn on the voltage now. Okay, I've turned on the voltage, and I don't get any voltage on the inductors here. Let me check at the bottom. No, I don't. If I take a look with the thing, I don't see, because the voltage currently is 0.8 volts, and the current was set at 4 amps. Okay, so I'm going to turn that off. Okay, so what I will now do is I will increase the voltage to 2 volts, and I'll hold it this way. So it's easier. You can see it as well on the camera, and check if anything blows up. There's nothing, so it's not taking any current right now, but let me just check, and I am not getting anything here. And nothing's lighting up. Let me check again. So I'm not getting anything on the inductors, but I'm not getting anything on the let me okay, so I would like to provide a small update. I was tracing around this particular card to see where exactly are the faults. I would like to show you under this one here on my thermal camera. Let me hold it this way. Now, what I've done is I'm injecting voltage, and I have initially started off injecting with smaller voltages, and there is no voltage that's coming on to the inductor coils. None of these, and there's no voltage coming in here. So these are fine. Now, so I'm going to inject directly 12 volts into this. 12 volts and 3 amps, because anything less than that, nothing is going to change. It will not show anything less than 12 volts. So I will show you what exactly I can see after I inject 12 volts. So I'm going to inject now. Okay. I hope you can see. You can see this thing here, this one here, there's one here and one here. So if I look at the hottest one is the one that's this one here. That is this chip here. The rest are lighting up, but it's not as bright as the one here. And this is the hottest one. So if I measure, there is no voltage. Okay, there is no voltage here. There is also no voltage here. None, and there is no voltage here either. Okay, that's here. I'm measuring, and I don't have any voltage showing here. But this thing is lighting up, and it's lighting up like a Christmas tree here. So the chips that are lighting up is one here. You can also see in the thing there is this chip here, and the chip that I removed earlier, that chip. So these are the chips that are lighting up. I will go ahead and remove this chip and see if my short goes away. So I'll just pause the video, get rid of all this, and go ahead and start to remove this chip. Okay, so the chip is off. Let's measure the resistance and see if it has made any difference. Let's take a look. And there you go. Now it's in almost 2.6, 2.8 kilo ohms. So we have found the short. It's slightly, okay, I think this is much better. So I'll show you. Our short is gone. So you can see that the resistance rising. It's now 3.5K, 3.6 and in rising. The board is still hot, absolutely hot. So our short is gone. I'll check if I have this part in stock. If I do have it, I'll replace it right now. Or let me check on my donor board. Yes, I do have this part, which I can borrow from here. There's one here. It's the same part number. On semiconductor 45491. There's one there. Should be another one as well. Yeah. The second one is here. So I'll take this one off and I'll put it over there. Okay, so we have installed the chip. Now, before we do anything else, let's take a look at the resistance and see if our resistance is okay. So this is the shorted chip. Let's take a look at the let me get a good ground point. And you can see it's kilo ohms, 3 kilo ohms, and rising 4, 16, 10. Okay, so it's rising. So our short is gone. Let's get rid of this wire. Okay, so I'll clean the card later, but before I do that, I'll just wait for the card to cool down, and then I'll plug in or give it some power and see if our card is ready to boot. So I'll just place the card here, let the card cool down, and I'll continue once it's nice and cool. Okay, so I have gone ahead and connected the card to the power supply. This is my power supply. And what I will check for now is to see if this card is getting or pulling the power that is required. So I will also test the voltage. Okay, first thing first, let's take a look if it's pulling the power that is required. And it's not pulling the power that is required. So it's pulling right now 0.13. Okay, so let's take a look what voltages are missing. So I have 12 volts. I have 12 volts here as well. Let's take a look what we have here. And I have 12 volts here. I have 5 volts. Let's take a look here. I have 12 volts here, 12 volts here. Let's take a look. I have 3.3. Let's take a look at this one. I don't have PEX. I don't have 1.8. So if I don't have 1.8, I will not have memory, and I will not have core. Okay, so I will have to trace and now trace why my 1.8 volt is missing. That is here. And I will, what I'll do now is try to figure out why my 1.8 is missing. I will do a bit of probing around, and I will get back to you with my findings. Okay, so I'll just pause the video, probe around a bit, and come back to you. Okay, I have found something which is connected to the 1.8 volt. Now, if you see here, this particular resistor, this is a 0 ohm resistor, this is a 0 ohm resistor, this is a 0 ohm resistor. So these three are 0 ohm resistors. Now the thing here is that this is connected to the 12 volt line, but these two are connected to the 1.8, and they are the V-in signal for the 1.8. Now if I measure the resistance on these resistors here, it's supposed to be 0 ohm, but if I check, if you take a look on the top left corner where I have the smaller screen, it shows me about 23 mega ohm, and that's not correct. It's supposed to be 0. Now let's take a look at the ones connected at the 1.8, and this one almost shows an open line. Now I'm almost digging into the resistor, and it's still an open line. The same thing here. This one is about an open line. So these resistors are probably burned. Let's take a closer look. Let's see if I can. So probably these resistors are completely gone. So what I'll do is I'll replace these three resistors, all these three, and see where we can go from there. So I will just connect and check what is the voltage that I get around those resistors before I go ahead and replace. Just a second. Let me switch over to voltage mode. Let me check on one side. I have 12 volts on one and 0.3 on the other. I have some low reading on one side and some reading on the other. This side I have 5 volts, and this side almost nothing. So I'll just change these three resistors and I'll get back. Okay. So will we get our 1.8 volt now? The missing 1.8 volt. Okay, so it's hot. I'll just let this cool down. Okay, so by that time, you can see that there's some kind of a liquid here. I don't know if it's flux or what exactly it is. It was there before I even touched this side, or it could be that it might it's from the previous repair center. Maybe they tried to do something, I don't know. But in the meantime, we can take some resistance and check. We don't have a short, which is a good sign. It's time for a voltage check. Okay, so what do you think? Will we get a 1.8 volts? Let me push this a little bit this side so there's no glare on the screen. Let's take a look. And we have a 1.8 volts. Okay, so we have 1.8. Do we have PEX? And now we don't have PEX. So we have a 1.8, but now we don't have PEX. So now we have to trace why we don't have PEX. So it looks like it's a never-ending story. It just goes on and on and on and on and on. Just to sum it up, initially we had a short on the 12 volts, tons of parts that were missing. We've gone ahead and replaced all the parts that were missing with the broken pins, missing resistors, capacitors, all that we've replaced. Then we've gone ahead and found our short. We've replaced our shorted chip. Then we found out that our 1.8 volts is missing. We found the cause of the problem were those 0 ohm resistors. We've gone ahead and found the 0 ohm resistors. Okay, just to sum it up. And now after doing all that, we have a 1.8 volt back. But now what we are missing is our PEX, and we are missing the rest of the voltages after that. So let me show it to you. We don't have PEX, but we have our 1.8. We do not have our memory, and we do not have core. So we are getting closer and closer, and eventually I hope we end up fixing it. And I hope by the time we get all the voltages back, I only hope that our core is good, because there's no other way to find out right now, because just by the resistance and all the other things, the core seems to be good, but the only thing is the actual truth would only come out once we get all the voltages up and running. Okay, so I'll just pause the video here. I'll do some more probing around, and I will get back with my findings. Okay, so after some probing, I have found another resistor which is supposed to be 0 ohm. There is this resistor which is supposed to be 0 ohm, and it's not. I will show it to you. Let me switch over. Okay, so I'll just make it slightly darker so that you can see. And let me just put this at the bottom so that you don't get the glare. I think that's much better. Okay. So if I measure the resistance here, this is a 0 ohm resistor. Okay, and if I measure the resistance, okay, it's very high resistance. It's about 41 mega ohms or 40 mega ohms. It's supposed to be a 0 ohm resistor. So this is yet another resistor which is blown. What I will do is I'll go ahead and replace this one as well. I'll just switch you over, center it. Let me find a resistor. Now I have 0 ohms. Okay. I feel I should just scan around and see some 0 ohm resistors this side, and check if they are 0 ohm or if they have, you know, changed their, uh, you know, uh, resistance value, because it's the third one and they were all in this particular area here. In this area, this one I've replaced, these two I've replaced, this one I have replaced now. There might be more. I am not too sure. As we go about testing it, we shall know. But as of now, this is what it is. And let me switch over. And see if we get our voltage, the required voltage. That's specs, core, and the rest of it. Okay, I'll just switch you to the other view. You can see it better. Okay, so, and we still don't have PEX, we don't have memory, and we don't have core. So we still don't have that. Okay, so we still have to trace and check why we don't have a trace. So I will trace the power good signal from the 1.8 and see where it lands. I will just probe around and I will come back with my finding. Okay, so I would like to make an update. Okay, now the 1.8 P good signal, comes in from here, and for the 1.8 to come in from here, it connects, the 1.8 connects here, and I have 1.8 connects here, and we get 1.8 out from here, which is the power good signal. Now that one, we don't get any 1.8 here. So if I show it to you, let me switch over. You can see here that I have 1.8 this side. Okay, let me switch so you can take a look. Okay, I think that's better. So if I switch here, you can see that I have 1.8 here. But if I switch here, there is nothing. Okay, now that 1.8 comes in from here. Okay, this is ground, this pin is ground, and this pin is also supposed to be 1.8. But you can see that the moment I drop it or turn it off, I can see some reading here that there is a leakage, voltage that is still around. So because of that, I see reading. The moment I turn it on, it drops it down. The reason this over here, I'm supposed to get a reading, which I'm not getting. Now, if I take a look here, I'm supposed to get 1.8, and I do get 1.8. But the voltage that is supposed to be present here is missing. So the moment I turn this on, the voltage drops because this transistor is switching that 1.8 to ground. And if I look at this transistor here, I have 12 volts. And that 12 volts is here. Okay, at this pin and between these two resistors. And through this resistor, there is a voltage that is supposed to go here, which is missing. Now, if I take a look here at this resistor, I turn it on, and I have only 2.93 or 0.2 volts. And I'm supposed to have a higher voltage here. Now, if I take a look at the resistance, now this resistor is supposed to be a 10K resistor. Now, if I measure the resistance here, it's almost like an open line. So even if, no matter what I do, let me take it here, it's like an open line. And this resistor is bad. Okay, so let me just try and change this resistor, and then we will take a look at this again. So I'll just switch this. Let me turn that off. Let me find a 10K resistor. Okay, so I found my 10K resistor. Let me see if I can. There you go. That's where I've written it, 10K. Okay, so let's get rid of that resistor, which is currently sitting over there. Now, let me also take a look at the resistor that is at the side. That's this one. Okay, sorry. Let me switch you over. So I have gone ahead and replaced this resistor. Let me also measure this one. Let me check what is the value that is supposed to be there. Okay, so it's supposed to be around 33K. And let me see what we have there. Okay, so that also shows like an open line. So I think I should replace that one as well. take a look. Now, what we are going to measure is to check if we get 10K from this end to this end. And we do. Let's check we get 33K from this end to this end. About 22, which is fine. Let's take a look here. Do I get 33K? About 25K, which is fine enough. From this end should be 0, and it is. Okay, I'll just check. I'll just switch over. Sorry. Okay, so now, since we've gone ahead and replaced that resistor, let's check if we get 1.8 volts, the one that was missing on this line here. And we do. Do we get here? We have our 12 volts here, and we have a 1.8 enable, which is going up. Now, since we have a enable here, do we have apex? And we do. Okay, I'll show it to you. Let me check the reading on PEX. So I'm checking PEX. Let me just lower the lighting so that you can see. Okay, so let me probe PEX, and you can take a look at the multimeter. Okay, maybe I've not got it right. Okay. There you go. So we have 1 volt on PEX, but PEX just shut down. And I can feel the GPU core warm. Let's take a look at core. I do. Let's take a look at memory. Okay, I see that we don't have memory. Okay, so the memory looks like it just starts on and just shuts down. Okay, I have memory now on this one. Do I have memory on this one? Okay, it's a bit strange. It looks like memory tries to start, but it shuts down. Okay, now I have, and now I don't. Let's take a look. Maybe I'm not getting a good contact. I have memory. On these two MOSFETs, I don't have memory. Okay, on this coil, I get memory, but on these two, I don't. And that's very strange because and on this coil, I do. This coil, nothing. This coil again, nothing. Okay, so it looks like it tries to start, but it just shuts down immediately. Okay, so we are inching closer towards fixing this board. We now have the PEX. Now the only thing that is playing up is the memory. Okay, so let's try again. Let's check. And this time we have memory. Let me check a different one. And now I don't. Let me check again. Or maybe there is some dirt here. Okay, let me, okay. So if I take a look at this thing here, let me move this. And if I turn this on, you can see the card now is detectable. It draws proper power, that is 2.7 amps. What I will do is put this on the bench and check if I can get this card to detect. Okay, so I'll take all this off and put it on my bench, and I will continue from there. So I'll just pause the video here, take this off, and let's see if this card is now working. Okay, so I have put the card on the bench. I will switch over to the other camera and the test bench. Okay, so the card is right now installed on the bench. That's here. Okay, so I will start the card. And let's check if we get picture. And the card is detected and we have a picture. So I don't have a penny cooler installed on this particular card. So I won't go ahead and wait for installing drivers or anything. I'll just boot into Windows and see if the card boots okay without any errors, because the cooler that is installed is a very tiny one. But basically, if I can say this card may be fixed, but let me see if it loads into Windows or it may shut down. Okay, looks like I just lost picture, but I think it might be overheating. I'll just shut it down and try again. Just a second, I'll just pause the video. I've changed my cooler and I'll try again. Okay, so I have gone ahead and changed the cooler. Let's start it up. We have a picture again. Let me boot into Windows. Let me adjust the fan. Are we going to lose picture? Okay, so it looks like we are losing picture after when Windows is loading. So instead, what I will do is I'll run a memory test, and let me check if that works. So I'll just pause the video and change my drive. Just a second. Okay, just a second. Looks like some issue here with my motherboard. Just a second. Okay, so I have fixed my motherboard. Let's take a look. So I'm going to run memory test and see if the test runs. Okay, so it's a pass. So the image that you see is from the graphic cards. Oh, sorry, I'm already into that drive. So I thought I wasn't in the drive. Let me run the command. Okay, looks like, and the card is on, the card is running, but I just lost display. It could be that the card has shut down. Let me just take some reading while it's still doing it. Let me take a look at memory. Do I have core? Okay, so it looks like it has shut down. The card has shut down. This is more of a thermal shutdown. It could be that some of the resistor or one of the resistor that is related to that line may not be delivering the voltage, and because of that it has shut itself down. Okay, so we'll get the card back on the bench. So the card is working. There is no issue with the memory. I've just run the memory test successfully, but after a short while the card shuts down. I'll just pause the video here and let me get the card back on the bench. Okay, so I've removed the cooler back again. Now there are two things here. One is we lost another capacitor. When I put the cooler, the capacitor just popped off. One. Number two is now when I connect the voltage, we don't have PEX. I'll show it to you. Let me connect this power supply. I measured the voltage while the card was on the bench, and I found that the PEX was missing. I'll just put this thing here. So we have all the other voltages. Let me check if on the bench I have the same thing. Now if I turn on, I have the core. Let me do this properly. Okay, so if I measure the core, let me make a good connection. Okay, so you can see that the core is there. I also have the memory. Okay, but I don't have PEX. So PEX is 0. So something on the PEX line is lost after we put on the cooler. So I'll have to trace it. I'll just check around, and we also have to figure out, to replace this capacitor. So if our card is, working properly, I will go ahead and replace those capacitors. But as of now, I'll just leave it the way it is. It's just that I have to trace the whole thing around again and check what exactly we are missing here. So I will pause the video, probe around a bit, and get back with my finding. Okay, so I have found a few things. Okay, even though we have the rest of the voltages, we are missing pecs. Okay, so if you take a look here, there is no pecs. Now, if we look at the voltages that are required, if you look here, we have 5 volts here coming in, and there is 5 volts on the other side as well. This is 12 volts, and we do have 12 volts that is coming in on both the sides of this resistor. Now, what we are missing, okay, well, before we go about the voltage that is missing, let's take a look at pin 2, which is the enable signal. Now, this is the enable, and we do get 1.2 volts, which is the enable signal here. We get all the voltages that are required except for the output, that is this voltage. So we have all the inputs but no output. Let's take a look at pin 5, which is the feedback pin. Now I suppose this is also going to be missing. That is 1 2 3 4 5. That is this pin. Yeah, it's this is the feedback pin, and it's going to be missing because we have nothing that is coming out of here. So we have all the inputs, but we don't have any outputs. So I will go ahead and replace this chip, and we will continue our thing, our tracing from there. So I'll just pause the video, get this card ready for the chip removal. Okay, so I would like to give you an update on the PEX. Okay, now if you take a look over here, you can see that there is a jumper that's going here. Now this is a pin. There are 3 pins here. That is pin number 7, 8, and 9. Okay, now 8 and 9 are connected together. 7 is separated. Now there is this 8 pin number 8 and 9 should be receiving 12 volts, but when I measured pin number 8 and 9, I was getting about 0.2. So not 0.2, but I was actually getting 0. So I was not getting any kind of voltage. So whereas I'm supposed to get 12 volts here, so pin number 7 is supposed to connect via the 0 ohm resistor to the 12 to the 8 pin number 8 and 9. Now when I check pin number 7, I'm getting 12 volts here. I'm getting 12 volts here, but I'm not getting anything here. When I check the trace, there is the resistance was about more than 20 mega ohms. That means that there is no connection between these pairs, which is supposed to be there. I've verified on the schematics, and there should be a connection between these, and there should be 12 volts here. So I've gone ahead and jumped a wire between pin number 9 and this 0 ohm resistor. I'll give you a closer look. Okay. So this is what it looks like. I've jumped the wire. Now let's take a look if we get our specs. I will switch over so you can take a look on a bigger screen. Let me reduce the thing here, move this away. Okay, so we'll take a look at PEX and see if we get a PEX now, and we do. So the jumper has got the PEX back for us. Okay, so what I'm going to do now is I'm going to put this card on the test bench and see if the card is getting detected. So I'll quickly pause the video, put this on the test bench, switch my camera, and continue from there. Okay, so I have gone ahead and switched the camera. Let's start and let's see if our card is detected first. If it's detected, it should switch off. Okay, it is detected. You can see that the computer has switched off. Let's see if we get an image. There you go. We have an image. Okay, so I'll turn it off right now, and let me switch my hard disk. Okay, so I have switched over my hard disk. Let's see if it boots into Windows. I won't wait for it to load any drivers or anything because I don't have a cooler. It's just a card. There you go. We have an image. So the image that you're seeing is from the card. Okay, my Windows crashed. Let's check if it stays connected. And it does. So this time it doesn't crash on us. We have booted into Windows. I won't keep it running for long because I don't have a cooler. Or should I wait for the drivers to load? I think I will wait for the drivers to load. If the drivers load, let me make some arrangements for some extra cooling. Okay, so I've just put another fan there. So this time our card did not switch off. Okay, looks like it's doing something. Okay, let me reboot and check if my drivers have loaded. Just that the card is a bit warm. Starting the card again. And I have an image. Okay. Looks like it hasn't read my hard drive. Let me reboot. And our drivers have installed. So let's open Tech Power Up. Okay, my mouse somehow decided to die on me. Let's check if all the sensors are working, and it is working. Okay, there you go. My mouse is back. Let's take a look at the sensors. The temperature is high because there's no cooler. It's just running on a CPU cooler. Okay, so there you go. We managed to fix this card. We can call it a fix. It's a very long video. It's taken me about, I've been working on 3 hours a day, and it has taken me 3 days to get this card fixed. Today is the third day. I didn't want to give up on this particular card. It's just that I wanted to get this fixed. So just to recap, it was a long repair. It had almost every possible thing from broken pins on chips, right, to damaged missing components, and we had short circuit on one of the 8-pin rail. We had a missing 1.8. We had a missing PEX, and almost every possible problem that you could ever imagine with the power rails. We had it all. Finally, we managed to get it all fixed. I hope there is something that we all could learn. I have learned a lot. And if you like this video, please hit the like button and subscribe for more content like this. And that's it for this video. Thank you for watching, and have a good day. Bye for now.